section chapter 5.4 in Big Ideas, and it's like solving for radicals. So we're going to see them in square roots, cube roots, fifth roots, lots of different views. So we have this problem: the square root of 2x plus 30 equals x plus 3. One of the things that most students get nervous about initially is the fact that there are variables on both sides, and one variable is outside of the radical, one variable is inside the radical. So we can't just move things over. We can't move this x over because they are unlike terms. They wouldn't be able to be combined because one's in a radical, one's not. So the question is, how do we get rid of this square root? Well, much like when we solve for variables, we ask, what's the inverse? What's the inverse of square rooting? The inverse would be squaring. So what's going to get rid of a square root is a square. So when we square this left side, that's pretty simple because this radical is a grouping symbol. So we're squaring this whole entire thing. And the other mistake that students make is they write this. And that really is only saying, when you write that, you're saying you're only squaring the 3 because the base of the exponent 2 is only 3. If we want to square the left side and we want to square the right side, we're going to have to write grouping symbols. It's very imperative that we do that. It's important that we show our work that way. It's the right way to express squaring the left side, squaring the right side. So these will cancel, and that'll cancel out the radical. That'll leave you with 2x plus 30 equals, now the quantity of x plus 3 squared is x plus 3 times x plus 3. We cannot distribute this in there and make x squared plus 9. That would be wrong. So this is a binomial square, and we get 2x plus 30 equals x squared plus 6x plus 9. In Honors Algebra 2, you should know how to simplify a binomial square mentally. Now we have everything outside of grouping symbols, so now we want to set it equal to 0. We're going to use the 0 property in a second. So we want to set this equation equal to 0. We're going to move everything to the right. So we're going to move that to the right. So what we do to one side, we have to do to the other. Cancels, cancels, leaves us with 0 equals x squared plus 4x minus 21. Now I moved the items to the right because I wanted my x squared, my leading term, to be positive. I didn't want to move the other things to the left because that would have given me a negative x squared. And we need this to be positive. So there's going to be lots of different ways to factor this. We're going to factor it. We're going to turn it into the product of two binomials. There are different ways. I taught you a times c, a being the coefficient of x squared, b being 4, the coefficient of x, c equaling negative 21. So it'll be, I'm going to show you the a times c. So a is 1 and c is negative 21, which gives us negative 21. We need factors of negative 21, 1 and 21, 3 and 7. Now we need it to be negative, so we know our signs are going to be different. And so if they're different, we're going to look here, and this tells me that the bigger is positive. So they're going to be different. The bigger of the two numbers is going to be positive, so the other one's going to be negative. And that will give us, the sum gives us 20, and the sum gives us 4. So we're looking for the one that is equal to our middle term. In this case, a positive 4. So these two, in this example, I'll show you what ends up doing, because the coefficient of x is not always going to be 1. It's 1 here, it's 1 in this case, and many of the examples in this homework assignment, but we need to be honest with ourselves. Is we're going to have to factor at some point down the road where the coefficient, or a, is more than 1. And using a times c is going to be very beneficial. But we break this middle term up into these two. So you get negative 3x plus 7x minus 21. So we're just changing. It's still, if we simplified this line, we'd still get x squared plus 4x. And now we're going to factor by grouping. We're going to group these two. We're going to group these two. Pull out a common factor of x, you get x minus 3. Pull out a common factor of 7, you get x minus 3. And they both have an x minus 3. If we pull that out, you get x plus 7. You see that both of these products have x minus 3. If we factored that out, we're left with x plus 7. That's how we get our other binomial. And this is all equal to 0. And now we have the 0 property, meaning the product of two numbers equals 0. Then one of these two binomials must equal 0. This must equal 0 or this must equal 0. So we're going to set each one equal to 0. And we're going to solve in order to find out what value of x makes this 0. 3 would make this 0. And negative 7 would make this one 0. So my choices are either 3 or negative 7 for my x value. Now we can't just assume that both are solutions because there are stipulations. So we want to go back up here and check. Hey, what if we plug in negative 3 for this? Well, positive 3. My solutions are positive 3 and negative 7. Positive 3 or negative 7. So if we plug in a 3, we get 6 plus 30 is 36. Square root of 36 gives us 6. If we plug in 3 here, 3 plus 3 gives us 6. So that solution works. We know 3 is definitely a solution. Now let's try negative 7. If we put negative 7 in for x, we get negative 14. Negative 14 plus 13 gives us 16. Square root of 16 is 4. Okay, that's not a bad number. I can deal with that. But if we plug in negative 7 here, we get negative 4. And 4 does not equal negative, 4 doesn't equal negative 4. So we know that negative 7 is not a solution. I call it an exclusion. Some people think that it's, or somebody thinks it might be different than that. But the only solution for number 1 is going to be 3. We again go here. We can now speed this up a little bit. We're going to square both sides. We're left with 5x plus 1 equals 36. That's nice and easy, very straightforward. Now we're going to solve for the variable. We're going to subtract 1. We get 5x equals 35. Divide by 5, divide by 5. X equals 7. We can take a peek. 35 plus 1 is 36. Square root of 36 is 6. And 6 does equal 6. So 7 would be our solution. That one's probably the easiest problem in this problem set. Number 3, notice we have a cube root. So what's going to get rid of a cube root? A cube. So we're going to cube both sides. We're left with x minus 16 equals 2 cubed, which is 8. We're going to add 16 to both sides, and we get x equals 24. Let's check it. 24 minus 16 gives us 8. And then the cube root of 8 is 2, and 2 equals 2. So 24 is an acceptable answer. That works. That's, again, pretty straightforward problem. This time, before in question number 1, we had things going on inside the radical. So we couldn't get to that. We had isolated the radical on the left side, and we had a binomial on the right side. On this one, we have things outside happening to the variable, or to the variable and the radical. So our objective is to isolate the radical first. We got to isolate this before we can square it. So we have something being added to it, and we have something being multiplied to it. We're going to get rid of things being added and subtracted in this example. So we get negative 2 times the square root of 24x equals negative 24. We're going to divide by negative 2, divide by negative 2. We get rad 24x equals positive 12. Now we've isolated the radical. It's a square root, so we're going to square both sides. And we get 24x equals 144. Divide both sides by 24. And we get x equals 6. Let's go back, check our solution. 24 times 6 is 144. Square root of 144 is 12. 12 times negative 2 is negative 24. Plus 13 gives me negative 11. Left side equals the right side. Oh, let's write the solution set. I like writing the answer in a solution set. That's always nice. Number 5. So number 5, we again have something happening to our radical where our variable is in. So we want to isolate this. Something's being multiplied by it and something's being added to it. We get rid of things being added and subtracted first. We're going to subtract 7. So we have 2 times the 5th root of x equals 8. We're going to divide both sides by 2. And we get the 5th root of x equals 4. And what's going to get rid of a 5th root is a 5th power. So we get x equals 4 to the 5th, which is 1024. We go in, 1024 to the 5th root is 4. 4 times 2 is 8, plus 7 is 15. So that check works out. So my solution is 1024. Number 6, we again have variables on both sides. One is in a radical, one isn't. So we got to get rid of that radical. We're going to do quantity of that left side. And we're kind of doing a quantity. Again, remember a radical is a grouping symbol. X minus 6 quantity squared is a binomial square, which gives us x squared minus 12x plus 36 equals 3x. We're going to move this over. We're going to subtract it, set it equal to 0. You get x squared minus 15x plus 36 equals 0. We're going to do a times c. A, this is my a value, is 1. C is 36. 1 times 36 equals 36. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The signs are going to be the same. How do we know they're going to be the same? Well, we look at this. This is a product. Remember when we multiply two binomials, that third value is the product of these two positions. It's our lasts. I don't know if you remember that. This value is my firsts, comes from my firsts. And this middle value is the outside plus the inside. It's FOIL, first, outer, inner, lasts. So we know that this is a product. This value consists of a product, multiplying two things. The only way you can get a positive by multiplying two things is either both signs are both positive or both signs are negative. So we don't know what they are at the moment. We just know it's either both negative or both positive. Negative times a negative gives me a positive. Positive times a positive gives me a positive. Well, if they're the same, remember, this is the sum of our outside and inside. Well, that tells me that this is going to be the sum of two negative numbers or the sum of two positive numbers. Since this is negative, we know the signs are the same and they're both negative. So we go over here and apply that logic to our factor pairs. And now we are going to find out, we're going to combine those. Negative 1, negative 36 is negative 37, negative 20, negative 15, negative 13, negative 12. Which one of these is equivalent to my middle value, 15? So I know that my trinomial, when I break it into 4 terms, I'm going to use these values for this middle value. I'm going to split this up, and I'm going to bring my x squared down. I'm going to write negative 3x and negative 12x, because that equals negative 15x. And when multiplied, it equals 36. Plus 36 equals 0. I'm going to factor by grouping. Now, if you need to find out how to factor, you can go through my videos. Do a search for factoring trinomials, and you can watch multiple videos of me teaching you how to do a times c. We're going to factor out an x. You get x minus 3. We're going to factor out a negative 12. First term is negative, and you're going to get x minus 3 equals 0. They both have an x minus 3, and you're left with x minus 12 equals 0. These must be the same in order for you to pull that out. This a times c technique that I'm showing you in factor by grouping only works when those two are the same after pulling out the common factor. Broke the pen. I knew it was only a matter of time before I broke the pen. Now we got to go to backup. Now the noise is going to be a little bit different. Let's go here. So we have the product of two binomials that equals 0. We'll use 0 power. So one of these must be equal to 0. When x equals 3, that makes that term 0. I don't know why I do one and don't do the other. X equals 12. We know that when x is 12, this binomial becomes 0. So now we need to check and see, what if we plug in 3? If we plug in 3 here, we get negative 3. If we plug in 3 here, we get the square root of 9, which equals 3. These do not equal each other. So we know that this 3 is not a solution. Let's try 12. So 12 minus 6 gives us 6. 12 times 3 is 36. Square root of 36 is 6. That does work. That checks out. So 12 is a solution. So I'm going to put it in a solution set so my teacher understands. If you just leave both of these, the teacher is most likely going to assume that both are solutions. So we always want to write a solution set. That's the best way of showing your answer. All right, again, we'll move fast through here. We're going to square both sides. We get 44 minus 2x equals x squared minus 20x plus 100. You should be able to do a binomial squared that fast. Let's minus 44 minus 44. Let's add 2x, add 2x. We get 0 equals x squared minus 18x plus 56. Factors of 56, we know the signs are the same. So factors of 56, 1 and 56, 2 and 28, 4 and 14. We don't have to go any further. We know the signs are the same, and we know they're both negative. So negative, 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 negative 18. That's why I stopped there. I knew in my head that that was going to equal my middle. So I go here. I write my first term. I'm going to break this up into these two terms. Negative 4x, negative 14x plus 56. I'm going to factor by grouping. I'm going to look at the first two terms. They have a common factor of x. I'm going to factor out an x. I get x minus 4. I look at the second grouping. I'm going to factor out a negative 14. Yeah, negative 14, and we get x minus 4. That's not, yeah, that was pretty good. I know I did it right because both of these quantities are the same. They must be the same in order to do factor by grouping. So that produces x minus 4, x minus 14. Zero property, so I know my x solution is 4 and x equals 14 are my possible solutions. I'm going to go back and test them. So if I plug in 4 here, that gives me negative 8. Negative 8 gives me 36, so I get the square root of 36 is 6. If I plug in 4 here, I get negative 6. Those are not the same, so I know that 4 is not a solution. And now I'm going to test 14. So let's test 14 here. Let's erase some of these numbers. So if I test 14, I get negative 28, negative 28, negative 28, and 44 gives me 16. Sorry, so the square root of 16 is 4. I'm plugging in 14. 14 minus 10 is 4. These are the same values. So that works. And I should probably erase that. No, that's right. We can leave that. So I know 14 is my solution. That worked. So I'm going to put that in the solution set. So 14 is the only solution for number 7. Number 8. Ooh, this is kind of interesting. So here we have radicals on both sides. First time that both of them have been inside of a radical. We're still going to do the same thing. We got to get rid of the radicals. We can't get in them. We can't move them. We can't separate this into individual radicals. So we got to square it. So I get 4x plus 1 equals x plus 10. I'm going to subtract an x. I'm going to move my variables to one side, my constants to the other side. I get 3x equals 9 divided by 3. X equals 3. Let's plug it in. 12 plus 1 is rad 13. 3 in here gives me rad 13. So they don't have to be clean numbers. They don't have to be perfect squares or anything. We just need the left side to equal the right side. So rad 13 is equal to rad 13. So my solution is 3. Don't confuse my check solution, rad 13, to my real solution. My real solution to the problem for my value for x is 3. That's also another mistake I see students make quite often, is they use their check solution as their variable solution. Now this is another interesting one. We both have cubes, they're being subtracted, and they're equal to 0. Well, that seems like we want it to be equal to 0, but they're not multiplying each other. So we want to get this one of these radicals on the other side. Let's get rid of the negative one by adding the cube root of 8x plus 1 to both sides. We're going to add the cube root of 8x plus 1. That gives us the cube root of 2x minus 5 equals the cube root of 8x plus 1. Now we can cube both of them, cube it, and we get 2x minus 5 equals 8x plus 1. We're going to subtract 2x. We're going to subtract 1. We're moving our variables to the right, our constants to the left, and that gives us 6x divided by 6 divided by 6. We get negative 1 equals x. Go and check. So if we plug it in, what are we going to get? Plug in, what is it? Negative 1, did we say? Negative 1. Negative 1 gives me negative 2 minus 5 is negative the cube root of negative 7. Negative 1 gives me negative 8 plus 1 is the cube root of negative 7. And does the cube root of negative 7 minus the cube root of negative 7 equals 0? Yes, 0 equals 0. So my solution is going to be negative 1 works, and that would be my solution. Moving right along, number 10. Ooh, so before we've been working with problems in radical form, because they were written as radicals. This is in exponential form. So how can I convert this to exponential form? I can write this as an exponent. So I have 2, and the denominator is always going to be the root, and the numerator is always going to be the power of that variable, or that term, the base, the power of that base, x. And we get this. Now it looks kind of similar to the problems that we did prior. So we got to isolate the radical. We'll divide by 2, and we get the cube root of x squared equals 4. What gets rid of a cube root? A cube. So we're going to cube both sides. So we get, I don't want green, we get x squared equals 64. Now we have x squared. What gets rid of a square? A square root. So now we have to square root both sides. And here's where it gets tricky. When we take the square root of an even power, we have to introduce plus or minus because we're going to square it. So negative squared is going to be positive and a positive squared will be positive. And the square root of 64 is 8. So my solution in this problem, and let's check both of them, is going to be plus or minus 8. So plus or minus 8. So if we have 8 squared, if we have 8 squared, that's 64. The cube root of 64 is 4. 4 times 2 is 8. And then if we plug in negative 8 and square it, we still get positive 64. The cube root of positive 64 is 4, and 4 times 2 is 8. So that still works. So my solution is going to, both of them work. We say plus or minus 8. So that's a nice way of doing it. Here's the other way of solving this, keeping it in exponential notation. Equals 8. Let's divide by 2, divide by 2. We get x to the 2/3 equals 4. And what's going to get rid of 2/3 is 3/2. So we multiply both sides by the power of 3/2. This makes 1. So you're left with x, and then you have 4 to the 3/2. So 4 to the 3/2, oh, I can write 4 as 2 squared. And if I do 2 squared to the power of 3/2, oh, look at all this stuff. This is pretty good. We're going to write that plus or minus 8. So we have a power of a power. When we have power of a power, we multiply their exponents, numerator, denominator. You're left with 2 to the 3rd. 2 to the 3rd equals 8. So I don't know if you would have seen the negative part. So I don't know. That would have been very interesting how you would have derived the plus or minus. I don't know how you would have seen that. You can see it here. I don't know why this is, that's sort of understood. We do that all the time. Anytime you take the square root of a variable being squared, we have to introduce plus or minus. That's sort of known. I don't know why we know that. But this one would have we probably would have forgotten the minus. So radical form seems to be pretty good for us. Let's be aware of that. That's a tricky thing. As you get higher in your math, you get more complex. All right, let's subtract 3 from both sides. We get x to the 1/4 equals negative 3. I'm going to convert that to the 4th root of x equals negative 3. Now, any even root, the square root of, if we have the square root of something equaling a negative number, no number's ever going to pop out that is negative. You can't take the square root of something and it be equal to a negative number. Nothing. Square root of 36 equals 6. Square root of 81 equals 9. And the reason is because 36 can be written as 6 squared, and those cancel to produce the 6. That's the understanding, the idea there. So when we have negative 3, no value is ever going to pop out. No negative value, because what if we had the square root of negative 81? We can't write that as a square of something, because a negative, anything's always going to produce a positive. So this is going to be no solution. Not only because there's no 4th root that equals 3, but there's no 4th root that is ever going to produce a negative number. So this answer would be no solution. Another trick one. They're really coming up with some creative ones. So we have to be both back-to-back problems had negatives that came into play. So this can be written, I'm going to convert this. This is the square root of x plus 6 equals x. I'm going to square both sides. I get x plus 6 equals x squared. I want my x squared to be positive. That's my leading term. So I'm going to move this stuff over. And that leaves me with 0 equals x squared minus x minus 6. Factors of 1 and 6, or a times b is 6. Factors of 6 are 1 and 6, 2 and 3. Signs are different. The only way that you can get a negative in a product is if one is positive, one is negative, or one is negative, one is positive. So the signs are going to be different because that's the only way you get a product equaling it. Now we go here and we know that there's going to be leftovers are negative. So I know that my bigger number is negative, my smaller is positive. Because notice we get a -5 and a -1. So really important to be able to comprehend that part. So that's another little trick here to get our factor pairs correct. So my two numbers that I'm going to break my middle term into. So I get 0 equals x squared plus 2x minus 3x minus 6. Now we're going to factor by grouping, group, and group. Factor out an x, x plus 2, factor out a -3, x plus 2. I did it right because these are the same. So pull out the x plus 2, and I'm left with x minus 3. X minus 3. Zero property. What makes this 0? A -2. What makes this 0? A +3. Let's test them. -2. We plug in -2. Plug in -2. This gives me 4 to the 1/2. Anything to the 1/2 is a square root. Square root of 4 is 2, but that doesn't equal -2. So we know that this is not a solution. Let's check 3 now. 3 plus 6 is 9. 9 to the 1/2 equals 3. And we plugged in 3 here. Does 3 equal 3? Yes, it does. So 3 is my solution. 3 works. So 3 is my solution set. Number 13. 13, moving right along. Let's isolate. Ooh, oh, look at this. Okay, let's isolate. Divide by 2. That's okay. We get the square root of 11 plus x plus 11 equals x plus 3 over 2. Now let's square that quantity. X plus 11 equals, so what is x plus 3 times x plus 3? Woo! So there's a number of ways to go about doing this. So that's x plus 3 over 2 times x plus 3 over 2. So that is x plus 3 times x plus 3, which is x squared plus 6x plus 9 over 4 equals x plus 11. Okay, that's not bad. Let's multiply everything by 4. Get rid of these fractions. Cancels. We're left with x squared plus 6x plus 9. This gives us 4x plus 44. Let's minus 4x, minus 4x, minus 44, minus 44. We get 0 equals x squared plus 2x minus 35. A times C, negative 35, factors of 35, 1 and 35, 2, no, 3, no, 4, 5, and 7. Signs are different. Bigger is positive. Signs are different, and we get 2. So those are my middles. x squared minus 5x plus 7x minus 35. Factor by grouping. We get 0 equals, let's factor out an x, x minus 5, factor out a 7, x minus 5. 0 equals x minus 5, x plus 7. What gives me 0 here is a positive 5. Negative 7 are my two possible solutions. Positive 5. So 5 is 16, which is 4. 2 times 4 is 8. Okay, hold on. That's somebody calling me. 5 plus 3 is 8 divided by 2. Wait, what am I plugging in? 5. Yeah, 5 plus, oh, not divided by 2. Just 5 plus 3 is 8. So 5 works. 5 works. And let's try negative 7. Let's see what happens with negative 7. Negative 7 gives me negative 4. And I'm pretty certain that nothing square root is going to produce a negative number. So nothing times 2. The only way we can get a negative is if this ends up being negative, and you're never going to get a negative value coming out of there. But negative 7 is, what's that? 4. Square root of 4 is 2. 2 times 2 is 4. 4 does not equal negative 4. So negative 7 does not work. 5 does. So my solution set is 5. All right. We're going to stop here for the time being, and we will pick up in a bit. Is completely different. Now we move away from solving for the variable, and now we're working towards the graphing of radicals. So this is what we call a parent, the parent equation. And what we do here is, because this is in the black, that's the shape of what the parent is, and it wants to know what would the equation for G look like for graph G. So we have to look at its shift, and it has a horizontal and a vertical shift. So horizontally, so it's sort of, let's do G of x, or no, G of x. So whatever we see inside and whatever we see outside is going to affect the shape, the shift, or the transformation of that graph. So inside is going to be the horizontal. But the tough part about that is because it's with the variable x, it's going to be the opposite of what we see. So we're shifting this point and this point horizontally 1, 2, 3 to the right. So you would think that that is plus 3, but remember it has to be the opposite of what you see. So G of x is going to equal the square root of x minus 3. So that's our horizontal, and anything outside of it is going to be our vertical shift. Now, our vertical is our true vertical. So we see that it went down 2. So we're going to do minus 2 on the outside. So that's a little trick, a little key, nice little way of, and it doesn't look like it has a shrink or a stretch, which would be, and it also doesn't look like it's flipped over the over the y-axis or the x-axis. Those are the other 4 components that go into transformations. Here we have the graph of h of x, and equals the square root of x plus 4. So remember, that's on the outside. So the outside is vertical. So we would assume that it would be going up 4. That parent would be up 4 on the y-axis. So we would say, well, let's not do it black. Let's do it this. We would say that it is this graph. And then it says, find the domain and range. Okay, so domain and range. Domain is always going to refer to the x-axis, or x values. And range is going to refer to the y values. And we think of that as x, y is alphabetical order, domain range is alphabetical order. So looking at this graph, what are my x values? So my x values start at 0 and go to positive infinity. So we would say x is greater than or equal to 0. And then our range starts at 4, and that also goes up to positive infinity. So we would say y is greater than or equal to 4. Even though it looks like it plateaus, it goes on forever, and it'll go to positive infinity. There are no constraints here. All right, that's number 15. Let's move on to number 16. 16, we want to identify the graph. So now we have some shrinkage. It's cubed, so we know that it's going to go into the positive and negative. But we still have, and you really can't tell your shrinkage right at the moment, or your stretch, sorry, your horizontal stretch. But what we do see is this shift, and we know that the shifts are going to be inside. So inside deals with the horizontal. So what is positive 6? Remember, it's the opposite of what we see. So most students would probably pick this one, which is incorrect. So we got to go to negative 6. And this is actually our only graph where it's negative 6. So that makes it easy. So yes, this is our solution. And then our domain and range, even though, again, our x values look really easy, right? We know x are the set of all real numbers. That means from negative infinity to positive infinity. And here's where students struggle is with the y, the domain. So this is the range. And the domain is also all real numbers, because we know that even though it looks like it plateaus, it continues to go, and it'll go to positive or negative infinity for the y values. And even though it looks like it plateaus, it will continue to go until positive infinity. So it is all real numbers also. So your domain and range. And then I wrote, although these graphs look like they have limits, they actually go up and down to their infinities, and left and right. So the domain and range are all real numbers. Yeah, so this is the answer here. That's a tough one. That's a tricky one, definitely. Let me tell you once you understand it. Number 17, it says identify the graph. So remember, inside radical is horizontal axis and opposite of what you see. So we see a positive 3. So we're going to go negative 3 on the horizontal axis. Negative 3 takes us to this graph. Good. That's pretty simple now once you have these sort of memory or mnemonic memory aids or cues. Outside the radical is going to be the vertical axis. So vertical is on the y-axis, and we're going to go up 3. So that would be this graph. Another nice, simple problem. Number 19. Number 19 says let f of x equal the cube root of x and g of x equal the opposite of the cube root minus 1. Describe the transformation of the represented. So we know outside is going to be, outside is the vertical. So we know we're going to go down 1. So let's look at down 1. Where is down 1? Down, 1 unit down. Okay, well that's the only one that says down, so we can pretty much understand that is that. And then it's a reflection on the x-axis. And when that negative is on the outside, outside is reflection over x-axis. Inside the radical is reflection over the y-axis. Okay, so we're going to reflect over the x and 1 down unit down. So we're going to reflect over the x, and blue is the parent red. So we go 1 unit down. We see that point. So my answer would be G. Yeah. So it's going to be the reflection of the parent. Blue is the parent. Okay. Number 20. Number 20 says, solve the nonlinear system. So solve it meaning we're going to graph it. So we know what this graph looks like. This is going to be inside the radical as a horizontal axis, opposite of what you see. So that parent is going to be, it's going to be up 3. So which one goes up 3? That goes left 3. This one goes right 6. This one goes right 3. Good. So we know that this first one is going to be this. And then we should notice that y equals x minus 3 is a linear equation. It's a linear equation with a slope of 1 and a y-intercept of negative 3. So we would find one of the lines that crosses the y-axis at negative 3, 1, 2, 3, and has a slope of 1, up 1, right 1. So we know that this is going to be my graph. That is pretty straightforward. Now we can do a couple things. We can go through each of these. We can find out what value it shares, or we can look at this graph and go, okay, what point do they share? What point or points do they share? They share, that point is 3, 0, and this point is 4, 1. So we can look for those points, 3, 0 and 4, 1. That would probably be the easiest, or you can plug in each of these values and test each one. You can test it by plugging it into each of the equations. Plug it in. We see 0 for x, that works. And then we would have to try this one, 0 and negative 3. This equals the square root of negative 3, so that would be no. So this wouldn't work for both of this. Oh, wait a second. It should work for both. No, it doesn't work for the both because it's not a solution. Hello. So good. So we would test. That's a really slow and arduous way of finding those solutions. All right. That's it. Some good stuff in there. Good luck. Check back for more work.